that means that other people, if they can't watch today, they'll be able to see it at a time that suits them. Okay. Oh. Okay, now what I want to do is to share my screen. I've got a PowerPoint here. Okay, can you all see that? Yep. I'm looking at Mrs. George. Can you see that, Mrs. George? Yep. Okay, that's great. Thank you. Right. Okay. So this is the maths workshop for parents of children in year 3. I'm doing one for each year group. And what we're going to be looking at today is what will your child learn about? How does my child learn maths at Castlemead School, and how can you support your child to be successful at maths? Okay, that's another parent in. Okay. Can I go whole screen? Oh, I can. Wonderful. Right. So we're going to start off looking at the national curriculum aims. So I've got a little picture here because this is really what the national curriculum is based upon. So there are 3 main areas, and there are 3 key aims in the national curriculum. So when most people think about maths, they think about the computational and procedural aspect, which is why it's coloured blue. So all about calculating things and remembering times tables facts. Emma, if you could just mute yourself, that would be really great.
Yep.
Thank you. But of course, maths is not just about those things. It's about the conceptual understanding, the understanding of the ideas behind all of those things that we want children to be able to do. So when they're doing an addition, can't get my words out. When they're doing an addition equation, for example, and they are adding perhaps 2-3 digit numbers together, we want them to understand what the words digits mean, what are hundreds, what are tens, what are ones, and why do we add them up starting with the ones? What happens if we do something else, for example? What happens if we end up with 11 ones? What do we do then? And all of that. So lots and lots of conceptual work that goes on behind just being able to manipulate the numbers. And then finally, the other part of it is about problem solving, which is applying the understanding to solve problems. So if we look here then, so the first aim of the national curriculum then is becoming fluent in the fundamentals of maths. So all of, knowing all of those facts like number bonds and multiplication facts. And we do that with varied and frequent practice and with things becoming more and more complex over time. And then what we want ultimately is for children to be able to recall and apply their knowledge rapidly and accurately. And then the next aim is that children should be able to reason with their maths. So they follow a line of thought and they throw up ideas about what the relationships might be between numbers and ideas. They make generalizations. They might form an argument, so giving reasons why they think a particular way using mathematical language and ideas that we're teaching them. And all of that helps to really distill and reinforce ideas that they're learning and bringing together all of the ideas that they're learning. And then finally, they are solving problems. So they're applying their maths to a variety of problems. And some of those problems will be routine and familiar, and others will be less familiar. And really that's the mark of a child who's much more confident with maths, is that they can solve unfamiliar problems, things that they've never come across before, but using what they've learned to that point in order to do that. Okay, so I should say, if you have any questions along the way, please do feel free to chip in and I'll be very happy to respond to those. So if we look at the national curriculum for lower key stage 2, so your children are in year 3, children should become increasingly fluent with whole numbers and the 4 operations. So that means addition, subtraction, multiplication and division. And that will include number facts and the concept of place value, which is what I was using earlier on. They should develop their ability to solve a range of problems, including with simple fractions and decimal place value. So really beginning to learn those things. Oh, I'm always conscious that's my email that somebody might be trying to get in, but I can't. There's nothing there to make me think. I will just have a quick look just to make sure. Yeah, somebody is, but I can't see them. I will just have to carry on. Right, can you still see my PowerPoint? Yeah, okay. So, right, we were on that second bullet point, I think. So I was saying about children using their learning to solve problems, and the teaching should also ensure that pupils draw with increasing accuracy and develop mathematical reasoning so that they can analyse shapes with their properties. So when we're talking about solving problems, it's not just about number, it's also about shapes. And that they can use measuring instruments with accuracy and make connections between measure and number. So working between the two. So very often you'll find that a child is much more confident with number, or they're more confident with shapes and measures. But what we want to try to do is bridge the two and help them move easily between the two as well. Now, by the end of year 4, we want children to know their tables up to 12 times 12, but obviously in year 3, we're not going to be there. So they're still working on, in year 2, they have to secure their 2s, 5s and 10s. And then in year 3, they're working on their 3s, 6s and 8s as well. And then they'll learn the rest when they go into year 4. Some children are more confident and they might be moving into those other times tables, but they learn their 3s, 6s and 8s in year 3. And then finally, we want them to read and spell maths vocabulary correctly and confidently using their growing word reading knowledge and their knowledge of spelling. So those things are important as well, because children need to be able to express themselves and their understanding of maths, both through their spoken language but also their written language. So that's why we put so much emphasis on drawing out ideas in the lesson through discussions, but also by getting children to write down their ideas in their maths books, which we call maths journals. Okay. So in year 3, there are 7 different areas of maths that children learn about. They are place value, addition and subtraction, multiplication and division, fractions, including decimals and percentages, not so much percentages, more fractions and decimals, measurement, properties of shape, position and direction, and statistics. So statistics, we mean graphs and data. So, you know, bar graphs, that kind of thing. So how does your child learn about maths at Castlemead School? So we learn through a mastery approach, which has its origins in Shanghai and Singapore, but there's lots and lots of evidence that this is really successful and helps children to really secure a deep understanding of their maths. So the way that we do this is we make sure that the maths is achievable for all children. We have high expectations and encourage a positive can-do mindset in all children, regardless of their ability. And we aim to create learning experiences which develop children's resilience in the face of a challenge. So, you know, it's often maths can be challenging, but what we're trying to develop is a real resilience and a determination, willing to persevere when it gets challenging. But we also try to scaffold the learning so that into small parts so that everybody makes progress. the learning needs to be deep and sustainable. So lessons are designed with careful small steps, with questions and tasks in place to ensure that the learning is not superficial. Because what we want is to build on what has gone before. So that's the next point, really. So children's learning of concepts is seen as a continuum across the school. It doesn't just happen in isolation. It's building on what's gone before, bit by bit, step by step, so that they have that really strong foundation. Children learn to reason about a concept and make connections. So that links with that national curriculum expectation. But also the idea about children making connections, because when children make connections between different areas of their maths, then they have deeper understanding, and they're able to then use that reasoning much more confidently to do more complex things. It also frees up their working memory, so that means that their ability to hold things in their heads isn't compromised by trying to work out simpler things. They've got those things automatically, like, for example, their times tables, facts, so they don't have to sit there working something out when they're trying to solve a problem that involves much more complicated procedures. The next thing is about children developing conceptual and procedural fluency. So as we learn maths, the teachers move from one context to another using objects, pictorial representations, equations and word problems. And there are high expectations for pupils to learn their times tables, as I said earlier, and key number facts, so that it is automatic and have a true sense of number. So they have that depth of understanding. And the pupils are also encouraged to think whether their method for tackling a given calculation is appropriate, reliable and efficient, because what we don't want is them doing some long complicated procedure when they could have done it in their heads. So we want them to be able to think and evaluate what they're doing as they do it and think, well, is this the best way to do it? Is there an easier way for me to do it? And that's also is why we teach children about different ways to approach different things. Problem solving is central, so that develops people's understanding of why something works, so that they truly have an appreciation of what they are doing rather than just learning to repeat routines. So that's what I was saying, that we teach them to evaluate as they go along. And then finally, challenging through greater depth. So rather than moving them into the next year groups learning, which is what we would have done before 2014, we set children tasks that deepen their knowledge and improve their reasoning skills within the objectives of their year group. Oh, the lights have gone off. As part of our mastery approach, we use what's called the CPA approach. And so that refers to concrete, pictorial and abstract. So the concrete is providing children with objects and resources that they can move around to explore and demonstrate their understanding. And then pictorial refers to diagrams, images, drawings and models that they might produce themselves to represent their ideas. And then finally, they will use abstract things like signs, symbols and digits to represent their ideas. And this concrete, pictorial, abstract approach is a recognised process that children need to go through as they develop their understanding about a mathematical concept. And here are some examples. So you can see on the left where children are using the base 10 materials, or you might call them deans, so to represent hundreds, tens and ones, as they work out how to do a subtraction, so they can move things around and see what happens. Then as they become more confident with that, then they can start to represent their ideas with their drawings and diagrams. And then finally, you've got the abstract representation with what you would recognise as a normal standard representation. So how can you support your child to be successful at maths? This is really important with helping your child practice and work, remember number facts, supporting them with other more complex and challenging mathematical procedures and concepts. So for year 3, number bonds to 10, 20 and 100. So I've used that term number bonds a few times now. So by that I mean number of pairs that go together. So in, with number bonds to 10, things like 2 and 8, 7 and 3, 5 and 5. With 20, say 14 and 6, 10 and 10, 5 and 15, and with 100, you know, something like 25 and 75, 50 and 50. Those are examples. And then, as I was saying earlier, times tables in year 2, they will have learned 2, 5s and 10s. So in year 3, they focus on 3s, 4s and 8s. Your child might be very confident and might have gone beyond that. They might be less confident and be working towards this, and that's okay, that's what we expect. But in year 3, this is what they're exposed to. So if they can keep on top of that, you know, that will really help them. Counting in 50s and 100s, so, you know, 50, 100, 150, 200, and then 100, 200, 300, okay, up to 1,000. And then finding 10 more or less than any given number, or 100 more or less. And again, you know, what we would want really is children recognizing, well, what does the number look like when I add 10 or 100 to it? What happened? What does it look like? Is there a pattern? So I think that maths is very much about patterns. And I know that I like patterns, so I think that's why maths suits me. And I think that lots of children do too, but they haven't necessarily realised that there's that thing about patterns going on. So if you can draw their attention to it, and or give them opportunities to see that there are patterns, that will really help them. Doubles and halves of numbers to 50. So very early on, even in reception, children realise they seem to like doubles. Double 3 is 6 and so on, or half of 8 is 4. But then as they go on, they need to be looking at bigger numbers. Counting forwards and backwards in tenths, in decimals, so being able to say 0.1, 0.2, 0.3 and so on, or in fractions, a half, 1, 1.5, 2, 2.5, in quarters, a quarter, 2 quarters, 3 quarters, 4 quarters, 5 quarters, but then they perhaps would come to the realization that 4 quarters is the same as 1 whole, 8 quarters is the same as 2 whole ones, and so on. Counting in thirds, 1/3, 2/3, 3/3, or 1 whole, 4/3, 5/3, 6/3, or 2 whole ones. Okay. Right, top tips. Okay, so using positive language, I just can't tell you just how important this is. I have told parents off, I'm afraid, in the past, because some parents will say, oh, well, I was never good at math, and they'll say it in front of their child as if to say, well, it's okay that they're not. And so I would say to you, please, even if you feel that you're not, you know, it's not your strength, please don't say that in front of your child. Try to talk positively about maths. That is so powerful. And it will help them to have a positive attitude about maths. And if they have a positive attitude, then they're likely to be able to achieve more highly. The power of parent encouragement is just, you know, I can't tell you. I've seen it with my own eyes. I've taught for 26 years, and, you know, if children feel encouraged by you, they will respond and they will do well. If you have the opportunity to play maths games together, that's also really helpful. So you know, games often use mathematical and logical skills, which will help children. Even jigsaw puzzles help children to develop logical and spatial awareness skills. Board games with dice develop their counting skills. Other games like Dart, Scrabble and chess can be really useful. If you have the opportunity to learn the methods that your child is learning, then that's can be really useful. So you're helping to reinforce the teaching that's going on. I realise that that's not always possible. It's not always easy. I've tried to think about ways that I can help you, you know, trying to include it in my workshops, but there are so many things that I could teach you. I always find that really difficult, and I'm still thinking about what I could do. But I guess at the moment, if you're able to spend any time with your child when they're doing their maths learning online, then you will be exposed to that, to some of those methods yourself, and that will help. I realise that that's not always possible, and it is really challenging for you, but just do what you can, and really that's all you can ever do, isn't it? If you've got any ideas about what you think I might be able to do to help further, then I'm always happy to listen to those, and I will take that on board. Practicing reading the time. Children always find it difficult to read the time, particularly with analog clocks, so clocks with hands. We're surrounded by digital clocks and watches now, and it's much easier for children to read them, but they're still being expected to read an analog clock or watch in accordance with the national curriculum. So they still need to practice that. So if you happen to be walking by a clock or a watch on a wall, there is an analog clock, you spend the time, ask them what the time is and how do they know, or explain to them how it works. That would be really helpful. Fractions, if you can use fractions, just simple fractions, even if you're not too confident, you know, things like half and a quarter, very often in relation to food, that's a good opportunity to practice fractions. So if you have a half, how much will I have? If I cut this pizza into quarters and I have a quarter, how much is left? That kind of thing. Just make sure that you're talking about equal parts. That's really crucial. Times tables, I've spoken about that quite a lot already. When children are bored, you could sneak it in. You might make car journeys go by faster. Not that we're doing much in the way of car journeys at the moment, but you know, that you could use them perhaps when you're going somewhere or in a sort of moment. And you could challenge children by saying them backwards if they're a bit bored with, say, you know, repeating them all the time. Problem solving, so try to involve your child in just ordinary everyday problems. You might ask a child what's the best deal at the supermarket, or how much their pair of trousers are worth when there's 30% sale on in a clothes store. I mean, maybe for year 3 that might be a bit challenging, because I was saying earlier on percentage, you might not do that, but you know, if something's half price, how much would it cost? That kind of thing. Looking for the best deal if you're changing your internet provider or something like that. And then finally, play to their love of technology. Again, I'm really conscious that children are probably spending an awful lot of time on their devices at the moment, so you might not want to encourage them to spend too much more time on that, but obviously you're aware that there are all sorts of wonderful apps and websites that children can use to practice their skills. And on the next slide, there is a list here that you might find useful. So many children really like Times Table Rockstars, and that's a really good way of children and you tracking their Times Table learning. And then the teachers can see that at school, so we can see how they're doing. It is personalised, so I think, you know, it's really good, but hit the button if they're not too keen on Times Table Rockstars. Hit the button. It's not personalised, but I know that it's very popular amongst the children. BBC Bite Size has, you know, if a child's stuck on something, you could look there, but also the White Rose. Lots of teachers are using the White Rose for teaching and learning now. So the website's there, so you can access that. If there was a particular maths word that you were stuck on, that you were finding it challenging to explain to your child, the Maths Dictionary for Kids is good. If you wanted something more challenging, Enrich is fantastic. I'd encourage you to go there. Third Space Learning, their blog is really useful for you as parents, particularly in understanding the way that maths is taught now. And then my personal favourite is the Khan Academy. So if you want to explain how to do something, it is American, but the way that things are explained is really clear, and the ideas and the explanations are very much in line with the mastery approach. So I would really recommend that. So lots there to support you. And then, as I say, if you have any ideas or questions for me, then please do let me know, and I will do my best to answer those. Or indeed, if you've got any ideas about how I could further support parents, sorry, then I'd welcome your feedback on that too. So I'm just going to stop sharing now, and I will stop the recording.